Hi, I'm Jeff Underhill. I'm a compute specialist here at AWS, and I focus on our AWS Graviton2 processor. And today I'm here to talk about why you should be thinking about Graviton2 as you look to run your game-related workloads in the AWS cloud. So first we'll take a look at what is AWS Graviton2. Then we'll look at some use cases for Graviton2. What should you be thinking about running on these instances? What are the benefits of running Graviton2? Who is using Graviton2 today and what are they using it for? And we have some specific examples of game workloads, and then some pointers to get you started with Graviton2. So game services need to be highly available. They also need to operate with low latency and deal with varied regional demand depending upon the popularity of titles and services within specific geolocations. Not only that, but within the game workloads, there are specific services where you may need different mixes of compute, memory, and networking in order to provide the best efficiency for those workloads. Add to that, the workloads are bursty. The difference between your peak operation and off hours can be pretty large, and you want to make sure that you can scale to meet those peak demands, but also you want to be able to spin down that infrastructure when not in use to make sure that you're being efficient and not paying for resources that you're not utilizing. So in a nutshell, game services must support varied game types, modes, and that elasticity of the workloads. So Amazon EC2 offers the broadest and deepest compute platform with over 400 instance types and sizes available today. So this is really important so that you can get super granular on instance types and map in those to pretty much any workload and business needs you may have. This ensures that you're using the most efficient instance possible for any given workload that you need to run in the cloud. That choice includes a choice of processors. AWS has Intel Xeon Scalable processors. At the end of 2018, we also introduced AMD EPYC processors. Also at the end of 2018, we introduced the AWS Graviton processor. So Graviton is the brand for our AWS developed general purpose processors that power a variety of Amazon EC2 instances. And that's going to be the focus for the remainder of this session. So what is AWS Graviton2? AWS Graviton2 is a combination of custom AWS silicon combined with 64-bit ARM Neoverse cores. Specifically, Graviton2 is a second generation of Graviton processor. It has about 30 billion transistors and is built on a leading edge 7 nanometer process technology. So Graviton2 was designed from the ground up for running cloud scale workloads as efficiently as possible. And when you innovate across the entire stack, all the way down to the silicon, this allows us to innovate at a fast pace and also build and iterate on behalf of our customers and the specific needs of running your workloads as efficiently as possible in the cloud. So what does Graviton2 mean for you? So Graviton2 delivers up to 40% better price performance for your Linux and predominantly open source or own source based workloads. Graviton2 is available in a variety of instance families. Here we can see from left to right the memory optimized instances in the R family, so R6 and G is the designator for Graviton2 based instances, M6G for general purpose, C6G for compute optimized. At the end of last year, we also introduced enhanced networking with up to 100 gigabits of networking and 38 gigabits of EBS bandwidth with the C6GN. Earlier this year, we introduced an enhanced memory instance family with X2GD. Those instances have up to a terabyte of memory. And then there's also the general purpose burstable family, the T family with the T4G. And those are very cost efficient for peaky and spiky types of workloads. So Graviton2 has broad workload applicability. I mentioned pretty much any Linux and predominantly open source or in-house application are targets for Graviton2. Here we have some example categories of workloads that we see customers running on Graviton2 today, ranging from game and application servers, lots of open source databases and in-memory caches. Microservices and containerized applications are a great fit. Media encoding all the way through to high performance computing, electronic design automation, and analytics workloads. So Graviton2's role in life is to deliver the best price performance within the instance families. This is a combination of highest performance combined with lower costs. So Graviton2 is 20% lower than the Intel x86 based instances based on on-demand pricing. And that combination of increased performance and lower cost is where we get this kind of general statement of up to 40% better price performance. We've seen customers achieve higher than that, but of course the performance characteristics are dependent on your particular workload and your particular access patterns. But fundamentally, you should see the best price performance within the instance families served by Graviton2. So I mentioned Linux workloads. I just want to quickly review the Linux distributions that are available for Graviton2 today. Here you can see in the commercial row at the top, Amazon Linux 2, Red Hat Enterprise Linux, SUSE, and Ubuntu LTS versions are all available for Graviton2 today. One point there is just to notice the version numbers. Graviton2 is a modern processor, and as a general rule, the more current the version of the software you're using, the better support it will have for Graviton2. In addition, there's great coverage here from the community distributions with Alma Linux, Alpine Linux, CentOS, Debian, Fedora, and Rocky Linux. And in addition to the Linux operating systems, both FreeBSD and NetBSD are also available. So I mentioned that containers and containerized microservices are great workloads for Graviton2. A key part of that is container-based workloads tend to be modern programming languages, current versions. Not only that, but containers allow people to decompose their applications into microservices, and thereby allows you to kind of pick off portions of your workload to transition first. The container technology also has a mechanism built in to allow you to build container images that can support both the x86 and ARM64 architecture. And this is what I mean here by multi-arch registers. Essentially, those registers can support multi-arch container images. So as far as runtimes, the Amazon Elastic Container Service, ECS, Amazon Elastic Container Service for Kubernetes, EKS, as well as self-managed Docker and Kubernetes environments are readily available for Graviton2. Amazon Elastic Container Registry, ECR, and Docker Hub both support multi-arch container images today, and that simplifies your consumption. You can just do Docker poll Nginx, for example, and you will automatically get the right container image based on the architecture where that call originated from. And then here are two open source projects that Amazon have published that are container related. Bottle Rocket, which is our container OS, and Firecracker, which is used for micro VMs. In addition to EC2 Linux, we have a variety of managed services that are already available on Graviton2. So these services can provide a quick and easy on-ramp to try Graviton2 to see some immediate term benefits. So RDS for the open source databases, MySQL, Postgres, MariaDB, Amazon Aurora, Amazon EMR for both Hadoop and Spark, Amazon Elasticache for Memcached and Redis, as well as Amazon Elasticsearch Service. And in addition to these managed services, of course, these are also good indicators for those workloads. If you choose to self-manage them, these are great workloads to run on Graviton2. But these managed services make it super quick and easy. And you can see here with RDS, you could realize up to 52% better price performance. In the case of Aurora, 20% improved performance, 35% better price performance. EMR, 35% lower cost and 15% improved performance. Elasticache, 45% better price performance. And Elasticsearch offers 38% improvement in indexing throughput, 50% reduction in indexing latency, and 30% improvement in query performance. So pretty big gains to be had, and like I say, a quick and easy transition to adopting Graviton2. So looking at the workloads and rating them, I guess, on the time and effort involved to transition. At the top of this chart, you've got the managed services I just talked about. Essentially, you just need to be on a current enough version of those services, and then you can transition to Graviton2. Super easy is EMR for Spark and Hadoop. this typically just works. The reason it says typically is if you have some of your own code you're running, then maybe you need to take a look at that and just make sure your things work between the x86 based instances and the Graviton2 instances. Quite easy. So Linux with interpreted and JITted languages. Examples include Java, PHP, and Node.js. Here you typically just pick the ARMY for the equivalent OS you're using, install your environment, and you're up and running. Bonus if it's containerized for some of the reasons I mentioned earlier. A little more involved is Linux and compiled languages. So examples here include C, C++, Python, and Go. It's a little more involved because they're compiled, so you have to recompile those applications for the ARM instruction set implemented by Graviton2. And then you just need to pay special attention to any intrinsics or assembly code that you might have there. Usually those are performance critical functions, and you'll want to make sure that there are ARM versions of those available to get the full performance entitlement from Graviton2. Some work but high reward is Windows modernization. So people looking at Linux and .NET Core, that is a great environment to run on Graviton2. The later versions of .NET Core have quite a few optimizations for the ARM64 instruction set. And then currently not possible are Microsoft Windows workloads, and that is because there is no Microsoft Windows Server version available yet for the ARM64 architecture. So as far as who's using Graviton2 today, there's actually a lot of customers using Graviton2. These are examples of customers where we have references on the Graviton website. I've included the link here at the bottom of the slide, so I encourage you to go check those out. In each case, there's a little reference that explains, what they're doing and the realized benefit from adopting Graviton2. And then I'd like to go through a couple of game-specific examples. So now.gg is running a mobile cloud service on AWS Graviton2. It's kind of interesting because Graviton2 being ARM-based, this allows them to run native versions of Android directly on those EC2 instances. And that avoids any architecture incompatibility issues that they may have running in emulation by running those mobile OSs in the cloud. Not only that, but they realize 40% better performance per dollar from running those workloads on Graviton2. And this empowers their mobile game developers to access a new spectrum of users because their games can be available via the cloud from anywhere that people can connect. And it also provides a consistent gaming experience because the games themselves are actually run on Graviton2 instances in the cloud, regardless of how they're accessed. Another example is OneGain. This is a China-based interactive game platform. They provide a simulated life game. In this case, they transitioned their RabbitMQ and Java workloads to Graviton2 and observed 40% better performance and 20% lower price from M6G instances versus the previous M5 instances they were using. And based on this experience, they are now looking for additional workloads that they can transition to Graviton2. CyberAgent is a Japan-based internet media services company. They operate a variety of web-based services for media, internet advertising, and game businesses. They are transitioning multiple of those services to Graviton2. Here's some results from the first service that they've transitioned, which was the .money service. Running that on Graviton2 has delivered 50 to 60% cost reductions for them. And partially that was because of the Graviton2 performance, which allowed them to get the equivalent performance while running on smaller instances. And then the Graviton2 instances are cheaper as well, and of course deliver increased performance. So again, based on that positive experience, they are now looking for additional workloads to transition. From a software momentum standpoint, Unreal Engine support for Graviton2 is available in the current 4.27 release, which is currently in preview. There will be further improvements coming in future releases. And to make this more accessible to additional developers, there has also been some merging back into prior versions. So developers looking to run games and applications on AWS can take advantage of Graviton2 there. There's also this great blog that posted recently about building that Unreal Engine and getting it up and running on Graviton2. So I include the link there. I do encourage you to check out that blog. So in summary, Amazon EC2 instances powered by AWS Graviton2 deliver up to 40% better price performance over comparable 5th generation x86 instances. Graviton2 is applicable to a broad spectrum of workloads. Here we've got some categories, but pretty much anything Linux and predominantly open source or own source based are good candidates for Graviton2. I just mentioned that. So these instances are supported by pretty much every popular Linux distribution you would expect to run in the cloud, commercial distributions as well as community distributions. There's also an extensive and growing set of independent software vendors who have support for Graviton2. And finally, all of these instances are available now. They're also available with local NVMe storage and bare metal instances if you need access to run your own virtualization environment. So to get started, here's a link to the Graviton website. We also have a getting started guide published on GitHub. Think of that like the software manual for Graviton2. Lots of pointers for transitioning your workloads and getting the best out of Graviton2. And with that, I would like to thank you for your time. Encourage you to go and check out Graviton2 and see what's possible for your game-related workloads. And if you have any questions or feedback, please don't hesitate to reach out to your account team via social media or via email. Thanks. Have a great day.